binary coded decimal. And binary coded decimal came about because what if we want to represent the number, say, 18 digitally on a display? Well, we'd have to individually represent the number 1 and individually represent the number 8 on two different digital displays. So binary coded decimal came about to be able to do this. Now, if you recall, decimal can have the numbers 0 through 9. How many bits do we need to represent these 10 different digits? Well, if you look at the highest one, 9, we're going to need to represent that in binary, which is 1001, so we need at least 4 bits to represent each decimal digit. So in binary coded decimal, you just take your decimal number and you represent it in binary using 4 bits, very similar to hexadecimal. So, 0 is 0 and 1 is 1 with 4 bits, all the way down to 9. Now, how would you represent the number 10? Well, if we were doing hex, we would represent that as A and then represent it as 1010. But in binary coded decimal, you're going to take each individual digit and represent it separately. So 10 in binary coded decimal is going to be 10. So in this case, if we wanted to represent 18 in BCD, binary coded decimal, we're going to get 0. We're going to get 1 and then 8. So let's just do one more example. Let's say we wanted to represent the number 367 in BCD. This is going to be 3, 6, 7. And conversely, you can go from binary back to decimal, or BCD back to decimal. So let's say we had this number. If we wanted to convert that back to decimal, just like in hex, we would be dividing it into groups of 4. And so we'd have a 3. Now this one is the number 11, and 11 does not exist in binary coded decimal because we don't have an 11 digit. So that's not going to do anything for us, so I'm just going to put that there's no output. And again here this is 14, so that's not going to do anything for us, so no output. So this is not a valid binary coded decimal number. A valid one would have digits 0 through 9 represented in binary. Okay, so why am I telling you all this? Well, it's because in your lab 7 through 9, you're going to be working on using the 7-segment display. And the 7-segment display is that little block on your board that has 4 different segments that look just like this. And they have, it's called 7-segment because there's 7 segments in each of them. I'm not going to draw them all, but to give you the ability to represent these numbers on a display. So you'd be able to represent 1, 2, 3, 4 different numbers, or you could create letters by turning on different segments in this display. So how is that going to work? Alright, so if you pull up your Nexus board manual from the PolyLearn site, it shows here a picture of this display, and there are first 4 enabling pins, AN0, AN1, AN2, and AN3. Now you have to activate AN0 if you want to turn on this leftmost display. You have to activate AN1 to turn on this middle display, etc. Now to turn on individual bits within the display, you can see there are 7 segments. 1 is A, 2, B, 3, C, 4, D, 5, E, 6, F, 7, G. So there's 7 segments to turn on different pieces of this display, and then there's also an 8th one for your little decimal point. So let's say now we want to represent the numbers 0 through 9 on our display. How are we going to do that? As you can see here, the numbers 1 will turn on segments B and C. The number 2 is going to turn on segments A, B, G, E, and D. And so we can create a table for binary coded decimal to a 7-segment display to make these displays turn on. Now, one important thing to note is that everything for this display in your hardware is active low. And what does that mean? That means that you have to give this a 0 signal in order for it to turn on. We've normally been thinking, oh, on is a 1, but in this case, you get on by giving the value a 0. Alright, so let's start making a table for a BCD to 7-segment display. So here I'll put our decimal digit first, our decimal digit, and then I'll show you our BCD for that, and then I'll show you our 7-segment code for that. So in decimal, the number 0 is going to be 0. In BCD, that's going to be 4 zeros. And the 7-segment display, going from segments A through F and then putting DP as the last display, I want to turn on A, B, C, D, E, F, and not G. So I'm going to go ahead and write this here. We're going to have A, B, C, D, E, F, G, and the decimal point. So everything that I want to turn on, I'm going to give a 0. So everything I want to turn on is everything except G, so 0. And I also don't need to turn on the decimal point. So there's going to be my 7-segment code, which here is 8 bits, to get the number 0. Let's try the number 1. So the number 1 is going to be 1. In BCD it's 0001. And then we want B and C to turn on. So those are going to be zeros, and everything else is going to be a 1. So you can go through this and create a table to convert all 10 digits 0 through 9 into BCD and your 7 segments. Then this is what you will be implementing as the core of your labs 7 through 9.